This study is about the effect of different degrees of wooden breast and white stripe myopathies on the quality of refrigerated chicken meat. Background: the broilers with fast growth and high carcass yield have contributed to the increase in the incidence of myopathies with white striping and wooden breast. The presence of breast myopathies provides changes in texture and in the technological properties. Objective: this study aims to evaluate the effect of the presence of wooden breast and white stripe myopathies on the quality attributes of refrigerated chicken meat. Methodology: chicken breast meat was obtained in a single batch from commercial unit in the western region of Paraná State, Brazil. The severity degree of myopathies in chicken breasts was performed by visual examination and palpation of the muscle by following the methodology proposed by Kutapan and contributors. The myopathy in chicken breast meat was classified into three groups: normal, moderate, and severe. After slaughter, pectoralis major was removed from the carcasses, N equal 30 per treatment, and cooled. Subsequently, they were packed in plastic bags and transported to the Poultry Experimentation Laboratory at the Federal University of Paraná in the Palotina sector. The PMs were randomly distributed, packed one by one in a polystyrene tray wrapped with a retractable film, stored refrigerated in a showcase lid at 4 degrees Celsius under light to stimulate typical conditions in the Brazilian market. At 1, 3, and 5 days of storage, 30 samples, 10 normal breasts, 10 moderate breasts, and 10 severe breasts were randomly removed for the meat quality analysis. The breasts were evaluated regarding their lipid oxidation, pH, cooking loss, water retention capacity, and most likely number for coliform at 45 degrees Celsius. To quantify the lipid oxidation, a meat sample was mixed with a TCA solution and homogenized in ultrathorax and after that centrifuged. The supernatant was filtered and mixed with the TBARS reagent. The mixture was boiled, cooled, and then the absorbance was measured at 535 nanometers. Concentrations were determined using a standard MDA curve using 133 tetramethoxypropane. The results were expressed in milligrams MDA per kilogram of meat. The pH was measured in duplicates at the cranial and caudal ends using a pH meter equipped with a penetrating pH electrode. Cooking loss was evaluated according to Deozotte and contributors, in which the breast samples were previously weighed, individually packed in polypropylene bags, and placed in a water bath at 80 degrees Celsius, and cooked until the internal temperature reached 78 degrees Celsius. Soon after, the samples were cooled and the losses were evaluated as a percentage of the initial weight of the sample. The water retention capacity of the breasts was evaluated according to Bridge and Silva, in which a portion of the breasts was removed and placed between two filter papers. The papers were then subjected to pressure and then weighed to determine the amount of water released. The result was expressed as a percentage of exuded water from the initial sample. The shear strength of the breast was measured using a texture analyzer equipped with a Warner Bretzel blade according to Honeywell, configured with a 5 kg load cell and a crossing speed of 1 mm per second. The breast was cut into rectangular pieces of 1 square centimeter cross-section, 10 pieces per breast, being cut perpendicularly to the fibers. Microbiological analysis was carried out for all chicken breasts, according to the limits established by the RDS Resolution number 12 of January 2nd of 2001 from Anvisa, which the maximum limit of coliforms at 45 degrees Celsius per gram is 5 times 10 cubed, in order to verify the microbiological quality of the samples. Coliforms at 45 degrees Celsius were expressed as the most likely number per gram of sample. Statistical analyses were performed using SPSS version 21 for Windows. The experimental design was completely randomized, with 3 treatments, normal, moderate, and severe, in triplicates and 3 storage times, 1, 3, and 5 days. The significance of the difference between treatments and storage times was confirmed using the Tukey tests at p less than 0.05. Results. The oxidation of the samples was influenced by the degree of myopathies and storage. Breasts with myopathies showed higher lipid oxidation compared to normal breasts. In addition, lipid oxidation enhanced with increasing storage time, being the greatest increase at 5 days of refrigerated storage. However, when the effects of both factors were assessed, no interaction was observed. The pH was altered by the occurrence of myopathies. Breasts with the presence of myopathies, moderate and severe, had higher pH values when compared to normal breasts. However, during storage, the pH did not change. Differences in cooking loss and water retention capacity of the breasts were observed. The presence of severe myopathy provided greater losses during cooking. In addition, cooking losses enhanced with increasing storage time. When the effects of both factors were evaluated, an interaction between them was observed, showing that the breasts with moderate and severe myopathies showed differences in relation to the normal chest on the first day of storage. On the third day, normal and moderate breasts showed similar cooking losses, not differing from each other. At the end of the storage period, all treatments differed, with graded losses for the severe breasts. Breasts with the presence of moderate and severe myopathy showed no difference during storage. Normal breasts, on the other hand, had higher cooking losses on day 1 and 3 of storage. The presence of myopathies has an effect on the shear strength of the breasts. Normal breasts had lower shear values compared to moderate and severe, which did not differ from each other. However, storage did not change the tenderness of the breasts. Coliform microbial growth parameters at 45 degrees Celsius were different between normal breasts and those affected by moderate and severe myopathies during storage. All breasts, normal, moderate, and severe, had counts below the limit of 5 times 10 logarithm colony, forming units per gram of coliforms at 45 degrees Celsius for refrigerated chicken, on day 1 of storage and starting on day 3. The moderate breasts have already exceeded the limit microbiological acceptable for refrigerated chicken meat. The normal and severe breasts suffered a posterior microbial deterioration, while the moderate breasts started the third day of storage. Therefore, a shelf life limit was reached earlier on moderate breasts than on normal and severe breasts. At the end of storage, the final count was similar for all types of meat. Conclusion. Our findings show that the presence of myopathies has a negative impact, not only in the visual appearance of the meat, but they can directly impact on the technological and microbiological properties of refrigerated meat, preventing its commercialization on this form. However, these meats can still be destined for processed products, and the knowledge of the effect of myopathies on the technological behavior of meats is of great relevance for the processes of development and improvement of meat products, which contribute not only to minimize economic losses but also to increase consumer shelf life.